Let we start our session with the minimization of four variable functions using K-map method, which are in SPOS form. Now, few procedural steps we have to minimize your function, which is in SPOS form. So, standard product of sum terms. So you are going to have your marks terms. So, based on your given problem or your given question, we have to choose your K-map, or based on your number of variables given, choose your four variable K-map. If it is a four variable, if it is five variable, you have to choose the five variable K-map. Identify your marks terms as given in your question. Thereafter, we have to, it is in the form of SPOS, so hence the marks term functional values are zeros. So put zeros into the corresponding cells of your K-map. Upon mapping, then we can go for the cell adjacency, so which makes a large groups of elements. So start with your large group, which is 16 cell adjacency. If it is not possible, then move with the 8 cell adjacency. So if it is not possible with the given marks terms, then we have to move to your 4 square adjacency. So then the least one will be your pair. Then so if a marks term, if it doesn't have any cell adjacency, it to be treated as a isolated marks term, and that isolated marks term must be represented as a sum term. So in your given minimal expression, so upon obtaining the groups, each group must be represented with the simplified sum term, and the final expression must be written as by taking all the sum terms must be multiplied, then we obtain your simplified expression. Upon having that simplified expression, then we are going to draw the logical diagram with less number of logical gates. Now let me take an example which is in SPOS form. So hence my function is a four variable with the given variables are W, X, Y, Z, and max terms given are 3, 4, 6, 7, 11, 12, 13, 14 and 15. So to this function, so almost we have here 9 number of max terms, and then we assign or we put your zeros into their corresponding cell. So this first cell is 0, and second cell is your 1. So third cell is your 3. So next fourth cell is your 2. So now upon mapping all marks terms, so now here this is the 1, this is 3, and here we have 2. So next the cell is belongs to 4, this cell is belongs to 5, and here 7, then here it is 6. Marks your cell number 8, K-map cell 8, this is 9, this is 11, and this cell belongs to 10. So this is 10, 11, and this is 12. So then this is 13. So here it will be 15, and the last one will be 14. So now mapping your function, so placing the functional values onto the corresponding cell. So 3, so we mapped 3 on third cell, 0. Next 4, then 6, 7, thereafter 11, we mapped a 0, 12, 13, 15, 14. Now upon mapping this all, so now let we move with your grouping. So now let me verify. So can we form, so only we have given with 9 marks terms, we can't form a 16 square adjacency which is double octet. Then we will move with the 8 square adjacency. So with this given 9 marks terms, we can't form a 8 square adjacency. Hence with the least possibility here it is only quad formation. So now this belongs to the first quad or the first group. So this first group is a 4 square adjacency, because here 3 is adjacent to 7, 7 is adjacent to 15, 15 is adjacent to 11, 11 is adjacent to your 3. So hence we can form scenario column wise. So these cells are adjacent, column wise these cells are all are adjacent. So we could form a quad. So now the minimal expression is, so here Wx for all these 4 max terms are different. Then For these 4 max terms, the common variables are y and z. The same variables are y and z. So now, so this group minimal expression must be written as a sum term. So as here it is yz are 1 1. So now as a sum term we need to write here y value is 1. So z value is 1. Hence y is represented with the complement. Z is also represented with a complement. Next, here we have a minterm 6 as well as minterm 14, and then here minterm 4, so maxterm 4 and maxterm which is given with the 12, so are adjacent. So we can form a quad because they are in left side of your K-map and right side of the K-map. So left side cells are adjacent to right side cells. So we can also form another group. So group 2 is also a quad. So now let me verify. Group 2 common variables are x and in a row wise and in a column wise z. So x value is 1. So group 2 sum term is x bar or of. So in column wise, so these for these 2 max terms it is yz is 0 0. These 2 max terms belongs to 1 0. So z value is same variable where y is different for this 4 max terms. Hence z value is 0. So z is represented without complement. So second group is having a sum term. So which is having a sum term of x bar or of z. Next, only one max term is left. So we can't choose a pair. If it is possible with a octet, you can go for that. So there is no possibility of an octet formation. So hence we were moving again with the already covered max terms. In order to cover uncovered max term, we are using the already covered max term. So here we have the group 3 elements which are sum terms are row wise. So the common or the same variables for all these max terms are wx are 1 1 where yz are different. So that was eliminated from your sum term which are different. So group 3 minimal expression is equal to w bar or of x bar. So hence our minimal expression must be multiplication of these all the sum terms. So which are y bar or of z bar, x bar or of z and w bar or of x bar. So like this, so we have to minimize your given function which is in SPOS form. Upon minimization, we need to draw the logical diagram using logic gates. Next, another example with the given max terms are 3, 5, 7, 8, 10, 11, 12, 13. So now we've mapped your function and there is only the possibility with the least pair adjacency is 2 square adjacency. So now this 2 square adjacency, first we have a red group, so which can have a pairing. So pair 1, let I take this as a pair 1. So pair 1 eliminates only one variable which is different. So here the common variables are a, so which is assigned with 0 for these 2 max terms, and CD are 1 1. So a or of C bar or of D bar. Next, the green group is again a pair formation. So where this green group max terms are having the common variables are B which is 1, so B bar, or of C is 0, so without complement, D is 1, so with the complement. Next, a blue group which is also one more pair, so third group, so which is having the common variable is A with the value of 1, so A bar or of, so column wise these are having the same variable which is CD with 0. So hence here A bar or of C or of D. Next, the last one, so which is also a pair, so which denotes, so the sum term is here row wise the common variables are AB where A value is 1, B value is 0, so A is represented with complement. In sum term, B is without complement. or of, in your column wise variable which is common is C with 1. So hence A bar or of B or of C bar. Now we will verify the minimal expression is having all these terms or not. So A or of C bar or of D bar, first pair. Next second pair which is B bar or of C or of D bar. Next third pair which is A bar or of C or of D. And the last one which is A bar or of B or of C bar. So this is your minimal expression of your given function. Next, third example, I have given total minterms are 7, sorry, maxterms are 7 maxterms and mapped your function. Now here, by just checking this possibility, we can form a quad here, and then so we can form a pair, a grouping, and one more pair. We can do it because they are in top layer and bottom layer. So now let me verify. So what will be its minimal expression of group 1? So group 1 is a quad. So minimal expression is AB is different, but CD are same variable for all the max term. So C value is 1. So C bar are of D. Next, second group is a pair. So this pair, so we can form a quad here because this in this cell, so this cell is almost it is 13. So 13 maximum is not there. So only we can have a possibility of pairing. So now here, so our minimal expression is row wise A value is 0. So A or of column wise, so C value is 0 and D value is 1. So hence A or of C or of D bar. Next, third group is also a pair. So now row wise, so this already I used your, so not to cover an uncovered max term, I'm using the already covered max term, so which is in top layer. So now this group is having the common variable in row wise is B value with 0. So B or of, so C or of D bar. So now let me verify the minimal expression. So first we have a quad. So C bar or of D is there or not? So in your given minimal expression it is there. Next, A or of C or of D bar and B or of C or of D bar. So which are multiplied to obtain your minimal expression. So this become the minimal expression of your given function. Next, we also have another example. So with the given max term, and there is a possibility only of doing your quad formation with the given max terms. So here 2, so next 6, 8, 9, so 10, 11, 14. So upon mapping your function, then we will go for the square adjacency. So 8 square adjacency is not possible. Only we have 4 square adjacency, which is a quad. So this is the one first group, which is a quad 1. So our minimal expression is, so for this all max terms, AB values are different. So CD value is common where C value is 1. So C is represented in the sum term. Minimal expression is C bar or of D. So D value is 0, hence it must be represented without complement. Now here, so in order to cover these 3 max terms which are not covered, so I am using already covered max term, which is your 10 max term. Max term 10 is used. Now, so this can form a quad, one more quad. So quad 2. So as these 3 max terms we can't pair because we don't have 3 square adjacency. We only have 2 square, 4 square or 8 square or 16 square adjacency. So quad 2 minimal expression is, so here column wise for all the 4 max terms CD values are different. Only row wise the AB values are common where A value is 1 and B value is 0. So if I write the minimal expression, then A is represented with complement since A value is 1. B is assigned with 0. So in your sum term, B value must be written without complement. Now, so upon getting that each sum term, we need to multiply all these group sum terms, then we will obtain your minimal expression, which is C bar R of D and of A bar R of B. So like this, we are going to minimize your given functions in SPOS form using K-map method.